Good evening, gentlemen. This is my first time reading off of a phone, so please bear with me. I hope none of my grammar shows up. Every year, the church celebrates with great honor the feast of the body and blood of Christ, or Corpus Christi. What is this heavenly food? The bread of angels that God gives us when we approach the Holy Eucharist? Blessed John Henry Cardinal Newman has a special gift of presenting complex matters in such a way that through his words, he helps us understand the complexity more the simplicity. Yet the profundity of the subject remains. He helps us to understand the awesome gift of the Eucharist through his straightforward meditation. This is the ability of a great teacher, such as Blessed Newman. Cardinal Newman begins a meditation found in the Meditations and Devotions with something even young children can understand, that through nature God provides for the beasts of the field, which he also created. In thee, O Lord, all things live, and thou dost give them their food. To thee do they also live, and to the beasts of the field thou givest meat and drink. They live on day by day, because thou dost give them day by day to live. But these beasts are not eternal. They are beings that are made in the image and likeness of God, as we are humans and are eternal creatures. And make thy grace supply the failure of nature. Do the more for me, the less I can do for myself. The more I refuse to open my heart to thee, so much the fuller and stronger be thy supernatural visiting, and the more urgent and efficacious thy presence in me. When our human senses fail, we pray for the grace to receive his body and blood in faith, so that by doing so, we are transformed within this bread of angels. Do you make frequent acts of faith when in the presence of the Holy Eucharist? When at work or at home, are you aware of where Jesus is the closest in the tabernacle of your heart? Do you devoutly cross yourself when passing a Catholic church as a physical reminder of Christ's presence? All these actions, though small they may be, will help us become more fully filled with the reality of the supernatural food. And in consequence, our love for Jesus will become more, quote, youthful, eager, and elastic, making us much better children of God. Amen.
Okay, guys, and now without further ado, I'd like to call up Dr. Burns.
Good evening. Good evening, gentlemen. And so what I wanted to talk to you tonight was the topic of starlight, courtesy of E equals mc squared, which is Einstein's famous equation, and our Lord Jesus Christ. And I'd like to start off with a quote from Genesis 1, verse 3. God said, "Let there be light." And indeed, there was light. So this is a discussion, take a journey with light, which has been with us for approximately 38 billion years. It obviously precedes us. And so this is a discussion from womb to tomb about light. From our inception and our history with light since the last 150 years in warfare and nuclear weapons or atomic energy for peace, which hopefully we could go with, will be the outcome. But it's a journey with, of, and for, and through light. How many of you are familiar, have heard the term the Northwestern Project? Does that ring a bell with anybody? This is the Northwestern University School of Medicine in April 2016 released a series of pictures about the conception and the light that occurs with human conception. But before that happened, there was a study that had been done at at the Feinberg Institute at Northwestern on infertility. The purpose of the clinic on the Feinberg Institute was to study infertility and the causes of it and how it might be approached. What they have found is that with the mouse, or with mice, looking at the fertilization of the egg taken from the female mouse and fertilized with the sperm from the male mouse, there was a release of energy. Very tiny, very small, but a release of energy. And they thought, well, this may be true in other mammals. And they tried to zero in on what happened actually with the human being. They found something very amazing, that the Feinberg Institute, first of all, let me make clarification, was funded by the federal government. Northwestern is a private university. It's in Northwest Chicago, home of the Bears and the Pope. So just in case any of you were disoriented. Well, what they discovered was that apparently using a human egg, they could not, by federal law, because federal law, as far as any outlet or clinic that used federal money, could not use federal money to experiment with human conception, the actual experiment or any experimentation on a human embryo or the creation of a human embryo by in vitro fertilization. It could be funded by a state university, funded by a state like the state of Illinois, or it could be funded by a private donation to like Stanford, but not the federal government. So what they did is they took a human ovum, human egg, and they took the DNA, they took the enzymatic coat or protein coat from a human sperm, not the DNA. And they reduced the experiment on what's called a petri dish, which had nutrients for this. And what they found was that the calcium, which covered the egg, left the egg when the sperm was introduced to the outside of the egg, which was, now not the actual DNA, because this wasn't actual fertilization, but it mimicked it. The protein in the enzyme in the coat of the egg, when it went towards the nucleus of the human cell, released light. Calcium came in from the outside of the egg, zinc came out and interacted with the enzyme in order to produce the light. So the fact of the matter is that we were not conceived in darkness. It was postulated that if this was done inside of a woman, a human being, in the fallopian tube, that the amount of light released would be even greater. So what I want to do is have you, if you can, go to your iPhone and enter in Northwestern University light of conception. Now remember, this is a model of what happens at conception, but believed to be the real thing. And then if you'll search, all right, what you should see is this.
You want the green?
Yeah,
Okay.
that's what you want. You want the green oval on your right. Your heading is Northwestern University Light of Conception. And what you should see on your iPhone is a paragraph, and on the right you'll see a kind of greenish, bluish orb. I just want to stop here and make sure those of you that can follow it have found it. Okay, there, you're a little bit ahead of it, Father. You want to go, this is the path, this is what you want to see.
Zinc spot.
Yeah. The heading is Northwestern University Light of Conception. And you hit search, and this is what your panel should show you.
Mm-hmm.
Are we?
We got it.
You got it?
Yep.
All right, now what I want you to do is tap your bluish orange orb. There you go. And you'll see a panel, and you'll see a group of 4 panels.
Yeah.
Okay, and then you'll see to the left kind of a greenish orb.
Yeah.
You got all that? That's a human ovum. That's a human egg cell. taken from a woman, placed on a petri dish for magnification. You're not going to see fertilization. We're not going to create a human embryo here. We're going to simulate it. And we're going to discover some of the biochemistry and physiology of fertility. Okay. Now, at 0 seconds, and keep your eye in the upper right-hand corner at the 2 o'clock level, you'll see a little red spot. Come over to, on the right, you'll see that red spot a little bit better. You can enlarge it, it can be a little larger. And I want you to just keep your eye and keep reminding yourself of that little red spot. You see that at 2 o'clock on the clock face? Yeah. That is the deposit of the enzyme protein from the human sperm, not the DNA. So we're not fertilizing a human being here. You can call these frames contact, penetration, fertilization, and then the final frame of energy. Okay? So what you're going to see is the contact of the human sperm on the surface. That's calcium. That's why that yellow or yellowish appearance is there. Then you're going to see the appearance of kind of the entry of the sperm, and you're going to see a halo of light there. Calcium is coming in, zinc is beginning to exit, and then from the lower left, where you have the reddish halo, that mimics conception. That's when the sperm DNA actually would merge with the DNA from the egg. That's conception. The one with the reddish light around it, that's when you'll really see the light resolve. And then finally, you'll notice this final ovum is about a little bit bluish, sort of aquamarine, compared to where we started in the upper left. The lower right is the finished product, if you will, of conception. Okay? Now, to view this and put it in sequence, go back over to the right side. On your right side, you see the calcium-covered egg. Okay? Touch it, and you'll see the whole thing in sequence. We got a picture of that? Yeah. You guys can see? Okay, you touch it, and you'll see it in motion.
Oh,
Entry, that's it. That's the whole thing in sequence. It'll repeat itself. You're going to have contact with the egg, entry, calcium in, zinc out, light released, and the final product in finish.
Like, would it take that long? Like
yes.
It would take 2 seconds?
1.3 seconds is what the whole process would take. That's us. That's you, that's me, that's what we all looked like. But remember, this is a simulation. We don't have the actual DNA of the sperm. We have the enzyme, we have the protein. But this shows to us what we never knew before, is we are not conceived in darkness.
They extracted the DNA so that it would be playing with people.
Right.
Okay.
But this is what it would look like. This is what. Yeah. Now, with our technology, we think that we can go up inside the fallopian tube. This would be arranged later on to find out what the light. The scientists who did this, the biochemists and physiologists who did this, figured the light at actual conception of a human being would be almost 100 times as intense in this, because it would be the real deal. Okay. So in other words, what they're thinking is, when it comes to infertility, is it not possible that infertility in human beings is related to the calcium-zinc exchange that takes place at real conception? And could that be an approach? This is, remember, 2016 that this was done, an approach to helping couples who are not able to conceive.
Right.
Okay, so there's that one. Now, let's take us a little bit further along in our development. Now, I want you to go to something else. And I want you to go to, and this is entitled, UTZ is medical lingo for ultrasound. So what you're going to put in your border up above is you're going to put in capital U, capital T, capital Z. That's the symbol for ultrasound, little medical lingo there. So you're going to put in ultrasound, capital U, capital U, capital T, capital Z. Okay? And this is so it should say capital U, capital T, capital Z, of human of human embryo, EMBYRO, at 6 weeks. And here we are in all our humble humanity, all of us, what we look like at 6 weeks. And press. Okay, you should see the paragraph, and then in your right-hand corner you'll see the embryo, and you can make it bigger by touching it and enlarge it. And this is at 6 weeks. So let's see what we look like at 6 weeks. Okay, now why 6 weeks? But that's something you need to understand. When we say a 6-week pregnancy, or we say the embryo at 6 weeks, remember the first 2 weeks are 2 weeks after the first day of the woman's menstrual cycle. Conception doesn't take place until 2 weeks into a woman's menstrual cycle, from the last cycle, going from the first day of her last period. So what you're really looking at is a 4-week creature. We say 6 weeks, but the first 2 weeks take up the time necessary for the mid-cycle. I hope you guys understand what we're saying here. So this little creature that you're looking at is termed as 6-week pregnancy, but it's really only 4 weeks of conceptus. It's really alive. I used to do these when I worked at the pregnancy center in Santa Monica. And you can see one indicator shows you can see that this is in the vacuum or the cavity of the uterine cavity. You'll see the little arrow saying yolk sac, which is for nourishment. And then as you come in, you'll see what it says, fetal pole. This has been enlarged for you. This is what we all look like at 6 weeks, actually 4 weeks of conception. About half a centimeter, a quarter of an inch in size. About the size of a pea. You and me. Infinitesimally, to the infinitesimal power of smallness in the universe.
Your screen is black. Your screen is black.
Oh, sorry about that. Well, that's another point we're going to bring up, Father. Okay, and you can progress it and take a look at other pictures. When I was doing this, my main objective was I was trying to help women who did not want to have an abortion, or were at least willing to be open to not having an abortion, because they wanted the ultrasound first to see what it looked like. 75% of those who did, that were abortion-minded, changed their mind once they saw this. This is at 6 weeks, and I assure you that when I was looking at this, you can see the heart. You can see that structure in the embryo, which is the embryonic heart, pulsating. You can see a human heart beating at 4 weeks. Yes.
Are you giving these women their own personal ultrasound?
Yes.
Oh.
Yeah, very often with their husband or their boyfriend or whoever comes in with them. And this is to provide them a real choice, to give them informed, truly informed consent. We didn't refer for abortions. If they wanted to go through with abortion, they were able to contact an abortion provider. Our job was trying to show them, number one, that the embryo was inside the uterus, not an ectopic. That's another reason why we're doing this. Because about anywhere from 1 to 5% of all conceptions are ectopic. They take place in the tube, and that can be life-threatening because it's going to rupture it. But one, is the embryo, the conception inside the uterus? Number two, is it viable? Is there a heartbeat, which we're able to track? At this point, that heart is beating at about 160 to 170 beats per minute. Wow. So is it in the uterus? Not in the tube. Number two, is it viable? Is it alive? Does it have a pulse? It does. Number three, we can measure, you can see the little measurement, you can measure and determine the estimated date of confinement, when the baby will be born. The EDC, estimated date of confinement. I was convinced, intellectually and emotionally, that I was watching God, Jesus Christ, at work creating a human being at this point. I was watching it in front of me. I could see it. So was she, and so was her husband and boyfriend, in most cases. The DNA, which you saw represented in the fertilized egg run-up that we first did, is in there in the nucleus of the fertilized egg, which is a human being. When I was in medical school, we used a textbook. It was called The Developing Human. The DNA code is being spelled out and represented as the expression of your arms, your legs, your brain, your face, your heart. That's where the genetic code, the DNA, spells out what it means. It's as if you consisted of 1 billion pianos representing all the cells of your body. The keys on every single piano, as is true of every piano in reality, the keys are exactly the same. The DNA code at every one of your cells, exactly the same. Yet, one set of those DNA will develop into a heart. Another will develop into your musculature, or your bone, or your liver, or your brain. Why we have all these symphonies of the heart, the brain, the bone, the muscles, exactly the same piano, exactly the same keys, but one symphony is that of the brain, another symphony is that of the heart, another symphony is that of bone structure, as the DNA code is spelled out. Very interesting, very fascinating. Chance? I don't think so. A symphony of symphonies, indeed. Now, one such creature among us, who at one time walked the earth among us, who fully matured as we all matured and was born, who I believe was created in God's image, was able to discover God's secret that he put inside the universe. What could be more fitting than that? That a human creature in the image of God would be allowed and led by God through the use of his brain to find the secret of God in the universe. This individual was Albert Einstein. And the next panel that I want to take you to, and let's just go to it, is, and you will see it, is, and I want you to put this in, ready? Okay. Type in capital E, put in the equal sign, space, capital M, small c, and a 2 for squared. And if you'll touch on that, you will see the most famous equation in history. Einstein's E equals mc squared. Energy equals mass times the speed of light squared. This is the Mona Lisa of mathematical physics. This is God's secret revealed into the mind of one such as us, so humble and so small, infinitesimal compared to the rest of the universe, yet able to find a secret that helps to explain the universe as God knows it, as God understands it. A little philosophy mixed in here with science. Now, by 1900, most of physics had been explained. We had Newton's laws of motion. You know, a body at rest tends to stay at rest. A body in motion tends to stay in motion. Force has to be used to accelerate mass, to make it accelerate. And if it goes over a distance, that's energy. That's work being done. That's a very simplistic rendition. E equals mc squared. If you take it apart, it's exactly that. It's mass over a distance being accelerated. If you put that in and plug it in, you'll get E equals mc squared. Now, the question came up among the physicists at this time. They were called the Copenhagen School. There was Einstein was a member, Copenhagen, Denmark, because those are what these guys like to meet, especially in the restaurants and the bars. And, you know, I don't mean to spoil your image of scientists and nuclear physicists, but they were human, and they like to eat, and they like to have booze, and they like to celebrate, and they like to talk. They also like to discover the meaning of nature and matter. And the Copenhagen School was composed of people like Max Planck, Niels Bohr, Schrödinger, de Broglie, Heisenberg, and Albert Einstein. Okay, so Planck noted in 1900 that when you put some electricity into metal or copper, whatever, he noticed under the scope that when that electrical energy was released, it was released as light. Interesting. So now they were trying to discover what they thought, not only what apples that fell on Newton's head, or what Newton's head was made out of, or what the apple was made of. You could see all that. They were striving to understand matter at its smallest particles. Up until this time, energy had been thought to be something sort of separate from matter. It was sort of kind of outside of it. It didn't mean that they had no idea that there was inner energy within matter, at least as potential energy, like chemical energy, which, okay, that was chemical energy being changed with a little help from the side of the matchbox into heat or light. This became known as the first law of thermodynamics. Energy and mass cannot be created or destroyed. It can be converted from one form into another, as you saw when the sperm wannabe was, thank you, sir, into light energy. And these guys in the Copenhagen school were starting to ask, well, just what is energy? What is matter? What is light? Isn't light made up of particles? Like, they were hung up on this idea of particles, little things that you could measure. Planck said that he believed that these little spots of light that were given off when the electricity was put in, and then the light came off as a packet of, or a quantum. Now, they thought, well, we're just going to bias towards light being made up of particles, so they decided, okay, simple experiment. Let's take a beam of light and focus it through a hole, one hole. And what you should see on the other side, if it's really just a particle, is a little spot left on a fluorescent screen. And they did it, and that's what happened. So then they said, we got this. Let's take a second light and put that through a second hole. And what would you expect but another little spot of light on a screen? Right? No. It's not what you got. What you got was a bunch of circles, concentric circles. Huh? Wait a minute. How come with two holes it acts like, well, it looks like a wave going through air or going through water? When you have one hole, it looks like a particle. Can reality be that arbitrary? You mean to tell me that the results you get about the nature of reality and physics is determined by the kind of experiment that you get? Experiments are supposed to have a consensus. They're supposed to draw together. They're supposed to say the same thing. Why with one hole you get a particle, and with two holes, instead of getting two particles, you get a wave? Is it possible that you mean to tell me that the kind of reality that you discover is based on the kind of experiment you perform? To see their dilemma, let's do this. Just turn your phones off. We can all agree on that. And you got a blank screen. All right, this is darkness, right? Let's perform an experiment to see what darkness really is. Okay, we're going to explore it. Are you ready?
Sure.
Turn your phones on. Uh-oh. What happened to darkness? The experiment that you're performing is changing the reality that you're trying to describe. You can't get at things at the lowest level of reality, said the Copenhagen school. We got a problem here. It seems that the reality that we're trying to explore or discover is altered by the kind of experiment we perform. Well, what are you going to do now? The answer to this was not to talk about what reality really is, but to talk about what it probably is. And then you got the development of quantum mechanics or quantum physics. And some pretty bizarre things began to happen because Einstein was part of this cruise. He was part of the idea of developing quantum mechanics. He was in it at the beginning. But they came up with some funny and very odd ideas to the effect that whatever quantum is, whatever a quantum of energy is or a quantum particle that we're trying to describe that makes up these little critters called the atoms, or the parts that we now call photons. They named them. They called them photons, the ultimate particles of reality, which are related to the atoms. Sometimes they just pop into existence and without a cause, and sometimes they disappear and go nowhere. Einstein said at this point, this is before 1905 when he really got into the act, he said, I refuse to believe that God plays dice with the universe. And he was a believer, he believed in God, but what he believed in was Spinoza's God, Spinoza the philosopher. Basically he said, yes, there is a designer, or a cause if you want to call it that, but he picked up his tools and left. He was a deist. He left, you're on your own. If there's evil or there's good, I'm not really having to do that. If you're immortal, well, we'll see. But Einstein believed that there was a reality behind what quantum physics and physics was trying to discover. There was a reality behind the universe. Spinoza said, and Einstein followed him up by saying, if you can understand the universe in terms of mathematics, and you can make equations that explain a lot of it, then there must be a mathematician behind the universe. You didn't create that mathematician, you discover him. Just as you discover that 2 + 2 = 4. You can't make it 5, you can't make it 3, you got to obey the laws that are imprinted in your mind. Where do those come from? It's a little bit like Plato, who said, we're not aware of what really is, we're aware of the cave or the shadow. Einstein therefore started calling quantum physics or quantum mechanics an incomplete theorem. And at this point, there was sort of a big argument in the Copenhagen school, and the guy said, look, Albert, you're like a connoisseur restaurateur. You go into a restaurant and you order prime rib and then potatoes and you got peas. You got to have your peas separate from your potatoes. Albert, it doesn't work that way. There are causes and there are effects. The effects sometimes come before the causes, and the causes sometimes come after the effects. And Einstein said, you call me a restaurateur? You guys, I know what you do. You go into the bars, you go to the back room, and you play tarot. You play games of chance to try to figure out your equations. You have made physics into a cheap magic show. Now, most people think of Einstein as kind of a, enduring old guy. Well, Albert could have a very sharp tongue. By the way, I love this guy. I love him. He's as close as I can come to a secular saint. Einstein constantly talked about the Nazarene. He was Jewish. He came from a Jewish home. He wasn't a practicing Jew, but he had enormous reverence for the New Testament and for Jesus. He loved the idea of Jesus. He loved Jesus. He said, if you Christians could be more like your Christ, he said it would be a better world, especially the idea of loving thy neighbor as thyself. So at this point, in 1905, Einstein came up with this idea of E = mc². The answer is that you don't have energy over here outside of the atom or surrounding it, and you don't have mass or the atom over here. They're inseparable. Energy equals mass times the speed of light. They're inseparable. They're two parts of the same thing. This could explain why it is you see light acting one way under one experiment and a different way in a different experiment. We're not talking about splitting the atom here. We're talking about the nature of light in the atom itself. Now, Einstein stipulated, in order to believe, now we're getting into the neighborhood of St. Thomas Aquinas. Einstein believed, he introduced what's called a fudge factor, because he wanted to try to avoid the idea of the universe having a beginning. He believed in a God of design, as Spinoza, a planner, a designer, not necessarily a first cause. He wanted to avoid that himself. Well, 1929, does anybody know where Mount Wilson is? Familiar? What sits on top of Mount Wilson? Hubble, the Hubble telescope. 1929, the scientists who were peering out into the edges of the universe discovered something called the red shift. What that translated means is that light changed its frequency as you move further and further out to the ends of the universe. That could only mean that the outer limits of the universe were moving away from each other and moving away from us at a rapid speed. They were accelerating. The only thing these guys could come up with to explain it, these are the astrophysicists, not the nuclear physicists. Now you're going to kind of sort of see how it comes together. These guys are saying, oh my God, there must have been some kind of, well, how do you explain this behavior of the stars except to say there was an explosion? Big Bang. Approximately 38 billion years before that. Now, we get into a situation, a 38 billion-year-old universe, and how do you explain it? In 2012, at Lucerne in Switzerland, a particle was discovered. It was called the Higgs God particle. And the theory sort of went like this. If the universe is really spreading out to its periphery, if you could rewind it like a film and rewind it, you would come to a point where the universe would start to get smaller, right? Because it's earlier in its development, and smaller still as you get closer to this explosion, this Big Bang, until you finally got something that was so small, it's smaller than a grain of sand on the beach. All that was, mass and energy, are in that particle. What led to that particle is the Big Bang, and that was when the Higgs particle, which was light, energy, donating mass to other particles. That's why they called it the God particle. Now, what happened here is the question became, well, if everything that was, including mass and energy, is collected 38 billion years ago in a particle, and there's nothing outside of it, and yet it came into existence from an explosion, the Higgs particle donated mass from light. What preceded at t minus 10 to the minus 1,000 power in time? Well, there couldn't be anything, and if there isn't anything, because there's nothing left, what brought something out of nothing? Thomas, at this point, Einstein and Thomas were in agreement that ultimately energy is conserved and mass is conserved. Aquinas and Einstein sort of were coming to the same conclusion. You don't get nothing, you don't get something from nothing. There's got to be a cause. The nuclear physicists and the astrophysicists were going, well, what are we going to do to test this? Well, we can't. We can't figure out a way to test time, because time has changed, and you can't have change without particles and energy. We can't come up with an experimental model to test the Big Bang as far as what preceded it, so we're just not going to comment on it. Well, Thomas had already commented on it in his proofs for the existence of God, which Einstein could kind of agree with as far as design was concerned. Oh, they tried. Stephen Hawking, in his last book that he wrote, Hawking tried to say that, well, what preceded it was quantum gravity. So there's nothing but quantum gravity. And then the question comes up, how can you have gravity without mass? That's what you mean when you talk about gravity. Are you going to start changing the definition of what you're talking about? Well, there must be multiverses, multiple universes before that. There's almost an infinite number. Or you had cyclic universes preceding the Big Bang, infinitely cycling universes. They tried to come up with an idea, well, it was just an infinite series that preceded the Big Bang. And here's a problem with infinite series. Infinite series have no beginning, right? Okay. So the infinite series has no beginning. The peculiar thing about infinity, infinite series don't have an end either. You can't have an infinite series in regression unless you have an infinite series in progression. If there's an infinite series before this with no end, you can't get a final now out of an infinite series that's infinite, has no end. In other words, this, I think Hawking got into my matchbox. All right. That didn't happen. That didn't happen. That's now. There isn't any now in an infinite series because there's no end either way. Infinite series, not a good idea. So I think, thank you, sir. I think Thomas had the better part of the argument. I think Einstein knew that. Okay, now, the next frame. What do you do with this E equals mc squared? Einstein had shown his point in theory, and some of this is backed by scientific experiment. Now I want you to go to another panel, and this one is called fission, F-I-S-S-I-O-N, versus fusion. Okay. Click it. Oop. Okay. I misspelled it. It's not you guys' fault. Fission. I want to take you to where we want to go. Versus fusion. Fission versus fusion, tap. Come on, baby. Well, mine isn't working too good. Yes, he's got it. Okay, you'll see a okay. If you, oh God help us. Okay, if you see the upper right-hand corner, okay, the upper one says fission, the lower one says fusion. You can enlarge it, and there you have it. Are y'all able to see that to some degree? Fusion, what fusion is, that's U-385 struck by a neutron. You'll see a little squiggle on the outside. That is a small amount of energy. And what do you get? From one particle, you get two smaller ones. Now, that's two smaller particles. If you look below, you'll see what fusion is. It's the precise opposite. It's taking two lighter elements, well, really, isotopes, deuterium and tritium. They're both isotopes of hydrogen. The lightest element of them all. U-385 is one of the heaviest isotopes of uranium. And what happened? You've got the two smaller ones fusing together to make one nucleus. And what is it? It's helium. A helium nucleus is equal to two hydrogen nuclei. And you'll see the energy waves are much bigger. A fusion reaction would be, according to energy, tremendously more powerful and tremendously more dangerous than a fission reaction. Back to you, sir. Now, what happens here is that in Germany in 1935 at the Kaiser Wilhelm Institute, a group of scientists were able to take a single uranium atom and they were able to shoot it with a neutron. This is not a sustained nuclear reaction. This showed in the results of that experiment a tiny amount of mass seemed to have been annihilated, but it was transferred, they showed it into heat energy. Okay, so if we look out at the stars tonight, it took our sun, don't look at it for too long, the sunlight that's impinging on your retina took 9.5 minutes to get there, traveling at the speed of light. Because now what we discover is the speed of light, that light is intrinsically involved with either fission or fusion or nuclear reactions. That means what you're looking at the sun is back into time. That event you're looking at happened 9.5 minutes ago. It's impinging on your retina. So fusion is the fuel of the stars. The stars that we look at night are gigantic fusion reactors, thermonuclear engines exploding thermonuclear bombs on their surface and radiating out heat and light. How is that possible? Because of the enormous mass of the sun. It brings together hydrogen nuclei so fast and so severely and so quickly that it creates helium and reduces humongous amounts of energy. But the interesting thing is this. Fusion reactors or fusion are much less radioactive isotopes or much less radioactive products revealed from it. It's much more efficient, much less costly, and much more efficient and easier to dispose of and safer in a certain way. Now, what happens is in 1942, in December 1942, under White Sox Stadium in Chicago, the first successful sustained nuclear fission reaction is conducted with a nuclear pile that they're able to put control rods into, because so damn many nuclei of U-385, they knew it would happen. It would happen very quickly if they didn't control it. Now, in 1937, because of the persecution of Jews under Adolf Hitler, which is when Kristallnacht was the night that they destroyed all the Jewish temples and Jewish businesses, in 1937, Einstein and his wife and child come to the United States, to Princeton. In 1939, I don't know how many of you saw Oppenheimer, the film, but in 1939, Albert Einstein writes a letter to the President of the United States, to FDR. He says, I know my colleagues are going to be working on the military use of my equations and what can be done with nuclear energy. Mr. President, I'm extremely concerned that in Germany, which is already 3 to 5 years ahead of the United States in any such research, will develop a nuclear weapon. It is of the utmost importance that the government of the United States launch into a program to develop that kind of weapon first, before they do, as a means of deterrence. Now, this became the famous Manhattan Project, and I referred to the first sustained reaction. The first step of it was the White Sox Stadium in 1942. Oppenheimer's counterpart in Germany was a man by the name of Werner Kurt Heisenberg. He was Germany's Oppenheimer. And they were 5 years ahead of us in the development of a weapon. It's believed that Heisenberg, who was a German nationalist and a strong anti-communist, wanted to develop a weapon to threaten Stalin and the Soviet Union with to stop the war. That was his purpose. He went to a meeting in 1942 where he met Heinrich Himmler, Reinhard Heydrich, the SS Oberfuhrer for Czechoslovakia, Romania, and Hungary. He was in charge of seeing that the trains that were taking the Jews to their deaths traveled on time. And he met Joseph Mengele, the SS surgeon who conducted the experiments on what is estimated to be 6 million Jews, and I don't know how many people know this, but it was almost 3 million Poles that were executed in those camps, along with almost 2 million Russian soldiers. About that time, the Germans were making progress with their heavy water plants. To deter the deuterium, the RAF flew a series of missions that bombed the Norwegian fjords, where the Germans were depuring their heavy water, which was essential for their atomic reactors to produce enough radioactivity to create a bomb with, and it was wiped out. Heisenberg had a moral conscience, and he slowed down and found excuses to literally sabotage German research. That's why we got the bomb first. Einstein thought that Germany would survive and Japan would surrender first, that we would get the bomb if we put our foot on it and develop the bomb first, and we could threaten Hitler with an accomplished bomb and force him to surrender as a deterrent. He never really wanted to see the bomb used. But the exact opposite happened. Germany surrendered first. The Japanese refused to surrender, an unconditional surrender, which I maintain was absolutely necessary. There would be no compromise with Japan, with the warlords who ran it, with Hideaki Tojo. At the time the bomb was dropped, the Japanese army was slaughtering and murdering men, women, and children in Korea, in China, in India, and in Southeast Asia. Okay? This was total war. The day the bomb was dropped, the Japanese army was murdering and killing these people. There was only one way to do that, was to take them out industrially. That's my opinion. Einstein was heartbroken. He was proven right. His equation worked. It worked in a deadly way. He still held out hope that perhaps someday that it would be used for peace. Here's the situation today. I would estimate that we have about 200 years left. This is my opinion. 200 years left. I've given the general this theory before. So we have about 200 years left of fossil fuel. That comes natural gas, coal, and petroleum. In about 200 years, if we continue the population of the Earth increasing at the rate it's increasing right now, we're up to 8 billion people. That will mean we don't really have 200 years. Yeah, that's when the last piece of coal will be along. In 100 years, your great-grandchildren will face a situation where there's going to be rioting, famine, war, possibility of an enforcement of either an extreme left-wing or extreme right-wing government over the earth to ration everybody. We have to start now, and I believe one way of doing this, you'll see this on the stock market. If you notice, two of the highest stocks right now are artificial intelligence, which demands enormous amounts of energy. Wind power ain't going to do it. Solar power ain't going to do it. If you want to launch satellites to the sun or put city block-sized radar dishes that can trap the electromagnetic radiation from the sun and turn it into microwaves and then break it down on Earth. By the way, this is all a way of avoiding a carbon footprint with very low, hardly any radiation. It's extremely cheap. If people were willing to sit down through the grace of God, maybe with meeting in the Vatican with the Pope counseling them, we could have a consortium with China, Russia, and yes, God willing, possibly the Arab or even Iran under new leadership, but that remains to be seen. You could have a consortium where we could advance nuclear fusion by decades. possibly within 10 years. But that's assuming everybody's willing to be rational and start with confidence building steps like taking cities, not eliminating all nuclear weapons right away because that's not going to work, but taking cities offline as a confidence building. It's up to us. Science is a gift to humanity, as is equal MC squared. It's up to us how we want to use this. I'm only making a suggestion of one way to go. Finally, the last frame is this. This has to do with our ultimate destiny beyond destiny as human beings. It's about an event that happened in a tomb 2,000 years ago in Jerusalem. And if you will, what you want to go to is shroud cloth.
What was that?
Shroud, S-H-R-O-U-D, S-H-R-O-U-D, cloth. And search. Okay, if you come up, you'll see the Shroud of Turin. If you switch it a little bit to your left, you'll see our Lord's head, and you'll see the body of the man. You can enlarge it a little bit with his arms crossed in front of him. It was rumored and believed that this cloth existed at the time of the Crusaders. It was sold to a very rich family in Italy and then to a richer family in France. In 1895, a French photographer at an exposition where the shroud was presented took a picture of the shroud, and this is what his film looked like. What is this on a linen cloth? This is a photographic negative. How, seriously, in God's name, do you turn cloth into photographic negative? It is 100% a surface phenomenon. There's no painting pigment in this. There's no paint. It isn't like someone superheated a statue and threw the shroud on top of it and scorched it. It's 1/100th of a millimeter in depth. It's all surface radiation. It's not paint. Nobody, no scientific technique, no scientific laboratory has been able to reproduce this product. This is the most studied icon and relic in human history. Nobody anywhere has been able to reproduce it. Yet in 1988, the commission that was studying it took a patch out of the shroud. What they didn't realize they were doing is they were taking a patch out of an area of the shroud that had been burned, and the nuns who repaired it put a linen patch in front of it. Radiocarbon-14 techniques works on this basis. The older something is, the more carbon-14 it has in it. Well, when they did their carbon-14 sample, this patch area that they looked at didn't have enough carbon-14 to make it 2,000 years old. It was thought to be only 1,500 years old. The church is considering letting sample it again, but in the meantime, physicists from Italy have conducted an experiment on a part of the cloud, a part of the shroud called radio scatter technique. It's highly advanced and very sophisticated. Radio scatter technique shows that this cloth is 2,000 at least years old. It dates correctly. I'm not trying, I think science is philosophy friendly, as in friendly to the way St. Thomas was trying to explain things from design and cause of the universe. I think science is religious faith friendly. I'm not trying to derive faith directly out of reason, but what I am trying to show is that science can demonstrate that it's reasonable. It's not, we don't have blind faith, but we have faith based on testimony, events, history, and now science. And this, more than anything else, hopefully will point the direction of grace, faith, and works of faith that we can proceed in. And the final thing I want to leave you with is from John 8, verse 12. I am the light of the world. Whosoever follows me will not walk in darkness, but will have the light of life. Thank you.